the domain. Can anyone give us the domain of this function? Please, anyone?
X cannot be positive 3.
That's it. Negative infinity, 0, 3, infinity. Perfect. Let's plug in 0 immediately. What do we get? When we plug in 0, what do we get? Yes, indeed. Good. Now, in the previous examples here, the numerator was 0 and the whole function was 0, so we didn't talk about x-intercepts. Here, the numerator couldn't be 0, so we didn't talk about x-intercepts because they don't exist. But here they do. So I have to find the x-intercepts. So how do I find the x-intercepts? Always set y equal to 0. What did we say? A fraction is 0 only when? A fraction is 0 only when? Anybody remembers when is a fraction 0? Only if and only if what?
Remain the same.
Only when the numerator is 0. So let's write this one more time. A divided by B is 0 only if A is 0. Please write it down somewhere so you remember this forever. A fraction is 0 only if the numerator is 0. If the denominator is 0, what happens to the fraction? How do we call it then if the denominator is 0?
Undefined.
Undefined. That's it. So we established if the top is 0, the fraction is 0. If the bottom is 0, the fraction is undefined. Excellent. Perfect. Good. So in this case, the numerator is x squared. So x squared plus x minus 6 equals 0. I'm going to write it again here. Can anyone factor this for us? So we can find the x-intercepts.
X plus 3 and then x minus 2.
Excellent. So we have two solutions, x equals and x equals. Great job.
Negative 3 and 2.
Very good. Awesome. Careful where you put them. Negative 3, 2. X equals 3. There is no discussion. This is a VA. There is no discussion about this, but I don't know the signs. So with 2.9 and with 3.1. I prefer looking at this. F of x equals x plus 3, x minus 2 divided by x minus 3. So let's plug in 2.9 in the function, and let's plug in 3.1. Let's do this together. Let's do this together. So let me show you how I do it. With 2.9, what is the sign of this factor with 2.9?
Positive.
Excellent. This one with 2.9. That's why it's so much easier on factor with if it's fully factored. 2.9, the sign of this.
Also positive.
Very good. But what about the sign of this with 2.9?
Negative.
Yes. What is the sign then on the left?
It's negative.
Very good. Good. Now with 3.1. What is the sign with 3.1?
Positive.
Good. What is the sign with 3.1?
Positive.
Very good. What is the sign with 3.1?
Also positive.
Good. So then the sign on the other side is?
It's gonna be positive.
That's it. Good. Everything is done. It's not symmetric if it only has one vertical asymptote. The last thing is here, which is, of course, connected to the slant asymptote. This is the horizontal asymptote when it has a horizontal asymptote, but now this is connected to the slant asymptote. So, how to find the slant asymptote? We know it's type 3. We know the degree of the numerator is by 1 unit higher than the degree of the denominator. We know there is a slant asymptote. How do I find it? Okay, here it is. Long division or synthetic division. X squared plus x minus 6 divided by x minus 3. X times what is x squared?
5x.
Very good. X times x is x squared. I'm not lying, but I have to change the sign. Negative 3x. I have to change the sign. Calculate. Final answer. X times what is 4x? And I cannot lie at the top.
4.
Positive 4. Good. So 4 times x is 4x. I have to subtract. 4 times negative 3 is negative 12, but I have to change the sign. Sorry that I have no room here, so the remainder is 6. So the function, that's why we studied section 3.3. So then the function f of x that initially was given to us like this, how am I going to write it? That's what we did in 3.3. Can any,
Plus 4 plus 6 over x over 3.
exactly. Well, this is the slant asymptote. Because this at infinity will go to 0. This is type 2. So at infinity, this will go to 0. So this is the slant asymptote. Y equals x plus 4 is the slant asymptote. Just the quotient. Only the quotient. Because this is very small, at infinity, this will disappear. So, the slant asymptote is x plus 4. Now, question. When I get the chance to graph x plus 4, will I graph it like this? Or will I graph it like this? In other words, I'm asking, does he have a positive slope or he has a negative slope? Agreed? Agreed that this slope is 1 and it will look like this?
Yeah.
Good. What does this mean when it comes to end behavior? From what to what? From,
Negative infinity to infinity.
that's it. That's the end behavior of the function because it has to follow the slant asymptote. So y equals x plus 4 slant asymptote. That's how I determine the end behavior based on what the slant asymptote does. If the slant asymptote does this, the function has to get closer and closer to it. If it does this, it's a different story. It's the opposite. But since the leading coefficient is 1, this is when I graph the slant asymptote is this, and the function has to follow this end behavior. Okay, I don't need anything else except my table. We read the table. That's why we summarized everything in the table. I have to start with the asymptotes. There are 2 asymptotes. The first one is the vertical. So this is x equals 3. And the second one is x plus 4. when x is 0, how much is y?
-4.
Careful. I covered it. 4. So when x is 0, 1, 2, 3, 4, y is 0. Now when y is 0, how much is x? When y is,
-4.
yes, 1, 2, 3, 4. Okay. Y equals x plus 4. Now we read the table. From negative infinity, crossing at -3, 0. Okay. From negative infinity, it has to follow the asymptote. Then goes up, crossing at 0, 2. Okay, fine. Then it comes down and crossing at 2, 0. I don't know again if it turns here or it goes further up and then turns. I don't know. We'll check that in a minute. And then comes to negative infinity. This is it. On the other side of the asymptote. From positive infinity to positive infinity, how is it possible? From positive infinity to a minimum to positive infinity. And we will have to find this minimum. Again, I don't think that the function will turn here, but it's possible. I graphed it as if it turns up here. If not, I will make the adjustment. We don't know in college algebra if it does this or it turns here or somewhere else. We need calculus for that. So that's why we graph and then we can make an adjustment. Okay, this is a sophisticated problem. I think I tried to make it very easy. Maybe I managed, but this is not an easy situation at all. I think it involves a lot of steps. Okay, so in y equals, clear, and we enter the function with parentheses for the top and parentheses for the denominator, plus x minus 6, and then close, and then divide by x minus 3 with parentheses. Very important. The calculator is not as smart as you are, so it needs help. So the second function will be the slant asymptote. I doubt the standard viewing window will work, but let's try. Zoom 6. It didn't, and it doesn't, because that minimum on the other side right here, this one is further up than -10, 10, 10, 10. So we have to make an adjustment for the viewing window. Okay, so I'll go to window. Again, I don't know how high y should be. I'm just going to say for now 50 and see what happens. I may have to change it to 100. Let me change to 100. I don't know, with a scale of 10. And let's see what happens. Good. So that was too much. Let me go back and change it back to maybe 50, as I thought initially. Good. Good. So the vertical asymptote, which is at x equals 3, does not appear. As you see, the function goes to negative infinity. I think it goes further. It comes from negative infinity, crosses at, what was it, at 0, 2. I think it goes higher to the right, as I thought. It crosses again at 2, 0. So this is at 3, 0, negative 3, 0, 0, 2, 2, 0, and goes to negative infinity. And then it's coming from positive infinity, coming to a minimum and going up towards infinity, approaching the slant asymptote. I want to determine this maximum. So I see the maximum is definitely between negative -1 and 2. So second and calc, I want a minimum. And I want, you can drag the cursor. Okay, that's good. Pass, get closer to 2. Okay. So give me the maximum. I think the maximum is going to be to the right-hand side of the y-axis. I wanted the maximum and I chose the minimum, so that's not good. I wanted a maximum. Okay. So pass the maximum, pass the maximum. Okay, give me the maximum, please. 0.55, correct, as expected. So the maximum, I can put it in the table. I go back to the table and I put in 0.55 and the maximum is 2.1. Now I want to determine this minimum right here. So now I go to second and calc. I want to find the minimum. Okay, and I want the minimum, so the 3.2. I'm going to say 3.2. No. 3.2. Okay. And I'm just going to drag past the minimum. Drag, 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 drag. Okay, I know I passed the minimum. Just give me the minimum, please. So the minimum is at 5.4. And the minimum value is 11.9. So this is a relative minimum, and this is a relative maximum. Relative maximum, or relative minimum. It involves a lot because of the slant asymptote, and because we had to find the minimum and the maximum and the minimum. So we had a lot of steps. We had to use the long division or synthetic division in this case. Both work in this situation. And find the slant asymptote and also graph it. Any questions? Any questions? We're going to graph another. But I know we have 4 minutes before I have to keep my mouth shut for 10 minutes. I just would like to look at any of these problems just for the first question. We're going to work on them. So the function given to us models the pH level, f of x, of the human mouth x minutes after a person eats food containing sugar. So let's say I take a cube of sugar right now, and look what happens. The pH drops dramatically within 6 minutes. I ate something with sugar, the pH level in my mouth drops in 6 minutes to a low point. And then it starts leveling off, getting closer to and closer and closer to the normal, which is 6.5. Use the graph to obtain a reasonable estimate to the nearest tenth of the graph, the pH level of the human mouth 42 minutes after a person eats food containing sugar. 42 minutes. What will you say after 42 minutes? I ate right now something with sugar, and 42 minutes later, the pH in my mouth will be roughly how much?
It looks like 6.0.
Perfect. After eating sugar, when is the pH level the lowest? After how many minutes is the pH level the lowest?
minutes.
6 minutes, very good. Now they want us to plug in 6 in this function. Okay, fine. No worries. I'm going to put the function in. 6.5x squared minus, so parentheses, 6.5x squared minus 20.4x, 20.4x, and plus I think 234, yes, plus 234, close, divide by, parentheses again, and the denominator is x squared plus 36. X squared plus 36. Now you have a lot of a very good understanding of these functions. You can look at the graph and say, oh, I know, it's type this and that. I know why it approaches this and has a horizontal asymptote. You learned a lot. Okay, so they are asking us to plug in 6. Fine. So it's 4.8. So the minimum is right here at 4.8, 6 minutes, and the actual minimum is 4.8. Okay, we'll continue from here with C, D, and E. I'll keep my mouth shut for 10 minutes.